Hello everyone, I'm Hugo Gaglioni of Sony's Imaging Product and Solutions Americas. Thank you for joining me today in this presentation. I plan to discuss the latest developments and workflows for the use of HDR technologies and products in live production systems. The main areas I will cover are as follows. First, the introduction of a newly developed metadata packet. We call it SR Live Metadata. This packet registers the settings and adjustment values of our professional cameras, which will be used for the perfect reproduction of HDR and SDR signals according to the creative intent of the camera shaders. Second, I will present conversion techniques now in use for input and output signal format throughout the production pipeline. Third, I will explain specific technical issues that could arise when mixing these conversion techniques. And I will present what Sony offers as a solution to guarantee high-quality HDR and SDR production. Our HDR production workflow is called SR Live, and it stands for Scene Refer Live for simultaneous creation of HDR and SDR programs. This picture illustrates the simultaneous production I am talking about. All CCUs and baseband processing units of Sony professional cameras can output HDR and SDR signals simultaneously. And we have developed a method for creating the HDR signal while maintaining the practice of shading or painting the cameras while watching the SDR displays. This, we feel, is necessary to avoid compromising the image quality of the on-air SDR program. The relationship between the HDR and SDR signal is defined by a gain difference between the two paths. We call it SDR gain. One of the key benefits of Sony's SR Live approach is that we can reuse the know-how of camera engineers when shading HDR cameras, as they remain vigilant not to compromise the image quality of the SDR program. The formats that we have selected for the HDR production are the S-Log3 and HLG signal formats. At the output of the production pipeline, our HDR converter, the HDR-C4000, perfectly converts the finished production master to the selected HDR distribution format, as well as the SDR signal for today's broadcast. And this workflow guarantees that the image quality and creative intentions decided in production can be carried all the way to the final viewer. The SR Live workflow has been used very successfully in numerous projects around the world, including major sporting, musical, and live media events. Once again, for the HDR-C4000, to be able to reconstruct a correct SDR signal, which matches the SDR signal from the camera's CCUs, it requires the information of the SDR gain value inserted in the cameras during the production process. While this technique has worked well, we have now decided to expand the technology even further. We are now introducing a technology we call SR Live Metadata. This metadata registers the creative decisions and adjustments of the cameras during program production. This metadata packet can travel over SDI interfaces from venues to stations, and it is used to maintain the quality of both HDR and SDR signals as defined by the camera shaders. This data can also be stored in the header of recorded files, so it can be reused over time to replicate the rendering intent of SDR for post-production and archive. The SR Live metadata packet shown here consists of 25 parameters that describe the operational settings of the cameras, including signal profiles, HDR-SDR gain differential, as well as HDR and SDR picture adjustments. This information can make HDR and SDR data streams and files self-explanatory for the various stages of production and post-production. This picture illustrates how the SR Live metadata travels through the production pipeline, finally reaching the HDR-4000 converter for visual verification of signal settings during the live production. The recording of this metadata packet can also be made in our camcorders. This action permits the processing of HDR recordings in post with our Catalyst Prepare editing application. With this information, Catalyst Prepare can replicate an SDR signal with identical image quality as that produced in our hardware-based HDR-4000 converter. We envision an SR Live metadata environment where the information can be created in remote locations and transferred to main broadcast and media centers. With this metadata, exact knowledge of the settings and adjustments of the acquisition cameras can be preserved for future post-production operations. Next, I will introduce some ideas related to picture looks in HDR live production. All TV formats exhibit specific picture appearances, which we call looks. The word look implies various levels of color appearance, color saturation, and image tones. Nowadays, people talk about a traditional look for TV formats that apply gamma curve, or OETFs, to the individual red, green, and blue color components. This process produces an increase in colorfulness of the image, making it look more impactful. TV formats such as S-Log3 Live, HLG Live, and SDR are examples of this traditional look. The word natural look we use to describe the appearance of this HLG format, as defined in the international standard BT2100. This signal format applies the look, or OOTF, to the luminance signal only, making the color saturation of the display image match that of the scene. Let me show you some examples of images that hopefully illustrate the differences in appearance of these traditional and natural looks. This image is an example of an SDR signal with traditional look. Please pay attention to the skin tones and colorfulness of the graphic elements. In this simulation of Sony's HLG Live, the brightness is elevated, as it should be the case for an HDR signal. However, the color appearance and saturation of the traditional look is maintained. In the case of HLG, this simulation shows a lower level of color saturation in the graphics and skin tones. Now I will discuss the topic of conversion techniques between SDR and HDR signal formats. These techniques for signal conversion are needed for different applications in program production, but they must be carried out with caution to avoid degradations in image quality. Display refer is a conversion process that maintains the look of a program when converted to a different signal format. For example, graded material, commercials, archival material will appear in the new format as the color is intended during the creation of the original program. Scene refer is a conversion technique successfully applied in matching SDR to HDR cameras, as the objective is to replicate the scene light captured by the cameras. We can also use scene refer techniques for graded material, but we must pay attention to look changes, which can happen when working in a standard HLG environment. I will now give you more details about the concept of maintaining the SDR round trip. In 2017, the International Telecommunication Union produced a very useful set of operational practices for the creation of HDR programs for live television. The recommendations very much resemble the signal workflows originally proposed by Sony in SR Live. In particular, the shading of the HDR cameras while watching the SDR signals. As shown in this picture, many positive results are obtained with this technique. For example, the use of scene refer production for matching camera looks. Only a single layer of production is needed for the HDR signal, The camera shaders view conventional SDR monitors with traditional look. A scene refer process is used in the down conversion of the SDR output. The round trip of SDR to HDR, back again to SDR, is established, resulting in the correct look for the SDR output signal. More recently, new guidelines were published with some additional recommendations. For example, scene refer should be used for tone and color matching of production cameras, while display refer conversion should be used for the preservation of the image looks in SDR commercials, graded and legacy material, slow motion server playbacks, etc. Production companies studying these new recommendations may end up feeling confused about what type of conversion technique should be used during the production workflow. This picture shows some of the new options now available for the use of SR or DR conversions in live production. In the end, the mixing of these conversion processes can result in image quality issues we call side effects. Let me illustrate two possible cases of these side effects. The first one involves the creation of the SDR playout signal by using display referred down conversion from the HLG master program. In the second case, a graded graphic element, for example, is display referred converted into the HLG process. Then it gets down converted to SDI by a scene refer process, say for the creation of an ISO feed to share this content with other broadcasters. As can be seen in this picture, the original SDR signal, perhaps from a live camera, is scene refer converted to HLG, which will insert its own natural look into the signal. Then, if a display refer technique is used for down conversion, the resulting SDR signal will exhibit a level of desaturation, hence not matching the original SDR source. In the second case, say the original SDR source is a graphic element, which is converted to HLG by display refer. Now the HDR signal maintains the color appearance of the graphic element. However, if a down conversion to SDR is needed using scene refer, the concatenation of both processes will result in an oversaturation in some of the colors of the SDR output. In both of these cases, the goal of the perfect round trip is broken by this side effect. Sony offers a solution to these problems by the introduction of HDR production formats with traditional look, the S-Log3 Live and HLG Live. These formats can be down-converted using a scene refer technique, which results in an SDR output maintaining the same look of the original source material. In this picture, with the use of HLG Live, the scene refer down conversion results in correct replication of the look of the SDR input signal, hence satisfying the objective of not compromising the creation of the SDR program, while still producing outstanding HDR signals. Some technical operators may argue that the full use of the traditional look may produce too colorful images, perhaps too different from the natural rendition of the scene. The use of the newly introduced HLG mile can result in lower levels of saturation and then closer in appearance to the look of this HLG format, but without the side effects in the down conversion to SDR. Therefore, we now provide two new modes of HDR operation when selecting the OETF of the production formats, the HLG mile and the S-Log3 mile looks. While these OETFs are standardized, what we can now offer are options for the production process in the selection of the intensity of the image appearance. In other words, the selection of the live, mile, and natural look. I would like also to mention that Sony is currently demonstrating a new series of 4K display monitors. We call them the PVM-X Series. These devices are UHD in resolution and exhibit 1000 nits of full screen maximum brightness, as well as a perfect matching of the chromaticity characteristics of our new flagship mastering monitor, the PVM-X 310. A very unique feature has been added to these displays. A future firmware upgrade will permit these monitors to carry a number of HDR conversion processes similar to those implemented in our HDR-C 4000 converter. These capabilities can be of great value for on-site grading or field production applications. To conclude, Sony is expanding the range of tools of HDR live production, not only the introduction of innovative new products, but also by the optimization of signal workflows, which maintains the high quality of today's SDR production as we evolve into the full usage of HDR media production. Thank you for your attention, and please keep safe.